Hello everyone, in this video I will explain you why do we need the provisioning process and why is it important. So let's get right into it. We all know that we can connect an ESP32 to a specific network if we provide it with the required credentials such as the proper SSID and the password. But what happens if you're working on a product and the user has to connect to its network? Does he even know how to reflash the ESP32 and change the network credentials according to its network? Obviously not. So there's a process in which you can connect an ESP32 to any network if you provide it with the required credentials. And this process is called provisioning. The provisioning process can work on two protocols, the Wi-Fi protocol and the Bluetooth low energy protocol. The difference between them is that the Wi-Fi provisioning works on HTTP protocol and requires less resources, but it's more complicated for the ESP32, whereas the Bluetooth Low Energy requires more memory. Today I will show you how to implement the Wi-Fi provisioning. How does this work? So first, the ESP32 is configured as an access point, and it will print a QR code which contains the protocol used and the SSID of the access point. I will connect with my phone by using a specific app, and I will scan the QR code. I will send the credentials of the network I want ESP32 to connect to, and the ESP32 will store those credentials in the non-volatile flash memory, in short NVS. Then the ESP32 module will reboot and will be configured as a station and will connect to that network. So let me tell you what do you need for this project. You need to download the QR code component. You can find in this platform ESP component registry. So go here and look for the QR code. This one. Copy this command and you will input this command inside the terminal, and the idf.py script will automatically add this component as a library inside the project. Also, you'll need an app which will be used as a provisioning, ESP soft AP provisioning. It is available on both Android and iOS. And you'll need the JSON library, which will be used for formatting the string which contains the SSID and the protocol used into JSON format. So you'll need only one file, so go here to single include and download this file, json.hpp. I will not download it because I have already done it. Open VS Code and make sure you have ESP-IDF environment installed. You can find it here in the extensions icon and search over here ESP-IDF, and it's this one. Now go to ESP-IDF, new project wizard, and choose a name for the projects, for instance Wi-Fi Prov 01. Choose a directory for the project as well. Choose the ESP32 board. I will be using the W rover kit, and choose the template. I will be using the simplest template because we will be implementing this from scratch. So open the project, and the language that we will be using is C++ because the JSON library works in C++. So go to main and rename the main to main.cpp. Delete the std.io. You need to add a dependency, meaning that you will need to include the QR code library. So paste that command. Okay, that's perfect. And you need to include the provisioning library as well. So go to CMake lists and add this command. Requires Wi-Fi provisioning. And also the QR code component, which is called express if to underscore QR code. And these are the files that we will need in this project. the ESP logDH used for logging data onto the console, the ESP Wi-Fi for the Wi-Fi driver, the FreeRTOS because the Wi-Fi driver works inside an RTOS environment, the Wi-Fi provisioning manager, which takes care of the provisioning service, and the scheme soft AP as well, because we're using the soft AP version of the provisioning. The NVS flash, which is just the partition of the flash memory, which will permanently store the Wi-Fi credentials, the QR code, which will helps us print the QR code on a terminal, the JSON file, which helps us convert a string into JSON format, and the max retry number, which represents the maximum numbers of trials to connect to the network. Let's define the Wi-Fi initialization function. It takes no parameter. Now we will need to initialize the NVS flash. And if the NVS flash now we will need to initialize the TCP IP stack in order to facilitate the network communication. We will need to create the default event loop, which will be constantly checking for events, for Wi-Fi events. Now we need to register an event handler for the Wi-Fi connection. So we'll have two instances, one for any ID related to Wi-Fi event and one for IP, such as IP assigning. So write this ESP event handler instance T. Oops, what happened? Wait. And another one for the IP event. Register the event handler. We'll have here an event handler that will be called whenever an event related to Wi-Fi happens. So write it like this. Now we will register the event handler to the event loop. ESP event handler instance register. The event base is Wi-Fi events. The ID of the event is any ID, so ESP event the address of the Wi-Fi event handler. Now additional arguments, we don't need editing, so pass null, and the instance, which is any ID. It takes it as a pointer, so pass the address of it. Now do the same for the IP event. And the ID of the event is IP event STA got. The only event related to IP event will be IP event star got IP, and will trigger the Wi-Fi event once the station gets the IP from the access point. And pass the got IP here. So we're getting an error. We need to know the parameters of the event handler, so go to the definition. Here you can find the parameters. This. Copy and paste it. Let's continue with the Wi-Fi initialization function. As I have already told you, the ESP32 will be working both as an IP initially and then as a station in order to connect to the desired network. So we need to create two network interfaces, one for AP access point and one for station. And you do that with the ESP native create default Wi-Fi SDA, and do that again for the access point. So basically what will this function do, will let ESP32 use the functionalities as a station and as an access point. As a station, it can connect to an access point. As an access point, it creates a local network and it allows other devices to connect to it. Now we will configure the network interface with the configuration structure. So the name of the structure is Wi-Fi init config t cfg equal. The fields of this structure are about the buffers used to send and receive data over the network, and another parameters such as the usage of the NVS flash. And we don't have to assign a value to each member, we can just use a macro Wi-Fi init config default. Alright, we will need to initialize the network interface according to this structure. ESP Wi-Fi init, the address of CFG, and then start the Wi-Fi interface, ESP Wi-Fi start. Let's go to the event handler related to Wi-Fi, and let's check if the event is related, if the event base is related to Wi-Fi, if the event base is Wi-Fi event. We will put the event ID into a switch statement. And the first event is Wi-Fi event SDA start, which is triggered by this function, ESP Wi-Fi start. When this event gets triggered, we will just connect to the network and also add a break statement. The next case is Wi-Fi event disconnected. We will print an error message, meaning that the ESP32 has disconnected from the network. Retrying. And now we'll take care of how many times has the ESP32 tried to reconnect to the network by using a variable. Retry count ++. We will declare it here as a static variable in order to assign it only once. The default value of a static variable is 0. And if the retry count less than the macro of maximum retries, we'll try to connect again. ESP Wi-Fi connect. You have to keep in mind that this function, ESP Wi-Fi connect, is only used when the ESP32 is configured as a station and it has the credentials of the network. Based on these credentials, it will try to connect to the network. Else, ESP logi will just output an error message. Connection error. Add a break statement. Default break. If the event base is related to IP event, meaning that the ESP32 has been assigned an IP address, we'll add an else if statement here. else if event base equal IP event, if ID equal IP event got IP, we will print the IP of the ESP32. So how do we find the IP of the ESP32? Well, the IP which will be sent in the event data will actually be stored inside the structure, and that structure will be sent to this event handler. So go over here, and the structure is called IP event got IP T, and we'll declare a pointer event equal, just typecast the event data to event data. And now we will just print the new IP. So go here, ESP log I station IP, and we'll have to use a macro which converts the IP address to a string. So use this macro IP_str. So we'll just convert the IP address to a string by using the IP_str of event IP_info.ip. Now we need to initialize the provisioning process. So declare another function here. Prov start, and we need to declare first a structure which will be related to what scheme we're using, what event handler we'll be using, and so on. So Wi-Fi prov mgr config t config equal like this. Dot app event handler will be the Wi-Fi provision handler. The scheme will be the soft AP, and we go here and can find the name for the scheme, which is this one, Wi-Fi prov scheme soft AP. And the scheme event handler. The main difference between the scheme event handler and the app event handler is that the app event handler is mainly used at the application level, and the scheme event handler is used at the protocol level. In the soft AP, this scheme event handler is not used. Now go again here, we will use none. So that's pretty much it related to the structure. No, also declare the provisioning handler. We will leave it like this. Now we will initialize the provisioning mgr init according to CFG. Now there's a function that checks whether the ESP32 has been already provisioned or not, and returns false or true. So we will need a variable bool is provisioned, wait, like this, equal to 0, and we will check if the ESP32 is already provisioned, meaning that I have already provided it with the required credentials with this function Wi-Fi prov mgr is provisioned. Now we'll need to, and there's another problem. What if I give the wrong password? I'll have to delete the data from the NVS flash and give it again. This is how the provisioning works. Once it receives the credentials, regardless of whether they are correct or not, the provisioning service will end. And we don't want to do that. We want to keep the provisioning service running until we receive the correct data. We need to call the function Wi-Fi prov mgr disable auto stop, and Here we need to pass the time after the service is stopped to release the resources. So resources will be released after 100 milliseconds. Now we will check based on the variable is provisioned if it's already provisioned or not. So if is provisioned, we will log a message, ESP log I tag already provisioned. We'll just configure the ESP32 as a station because it has the credential and connect to the network. Right, like this. ESP Wi-Fi set mode Wi-Fi IF SDA, and it will simply set it as a station. Now start the Wi-Fi. Else, if it is not already provisioned or provisioned service, we have to start the provisioning service. So write it like this: Wi-Fi prov mgr start provisioning, and we have to input the security level on which the service is running. So we will have to use the level 1, which will use a passkey. Think of it as a password, which acts as a shared secret between the ESP32 and the phone. So we'll use the Wi-Fi prov mgr security 1, no, over here. Now you can see over here second parameters. We don't need any parameters. Now we need the service name, which is just the ESP32 SSID. So we'll have to use like prov ESP, and the service key, which is called proof of possession. As I have already told you, it acts as a password. So pass the ABCD, a simple password, ABCD1234. Now we need to print the QR code so that we can scan the QR code and connect to the ESP32. Print QR. Let's declare the print QR function. Here the JSON library steps in. We will format the data into JSON format and convert it to the QR code. So write it like this: and Noman JSON QR string equal, and we have to input the version of the provisioning service, which will be the version 1, then the SSID, meaning the name of the ESP32, prov ESP, then the proof of possession, which is simply ABCD1234, and the transport, which is simply the scheme that we're using, either BLE or soft AP. I'm using soft AP, so right here, transport soft AP. Now we need to initialize the QR module based on a structure. So declare the structure ESP QR code config t QR equal ESP QR code default. Generate the QR code, ESP QR code generate address of config, and the QR string, which will be stored inside the QR code, that dump, because the QR code generator takes this parameter as a char pointer, and we'll have to convert the JSON object into a C string. So that dump method converts it into a string type in C++, and then we have to convert it to c.str. Here we have to say QR. My bad. There's one more thing. The provisioning event handler, which is here. I have to provide the right parameters. So go over here on the app event handler, go to the type, and here you can find on the Wi-Fi prov callback function T, you can find the parameters. Pass the parameters like this and put the event inside the switch statement. if the event is equal to the start of the provisioning, we'll just print ESP logi Wi-Fi prov start, obviously as a string. And the next event is when the credentials are received, when I send the credentials. So case Wi-Fi prov credentials received. Once this event is triggered, the credentials received are sent along with it inside the event data variable. So you can print the SSID and password that you received. Write it like this: ESP logi tag credentials SSID equal to string pass equal to string. When the credentials are received, the event loop passes the Wi-Fi stack config t structure, which contains the SSID and the password. Wi-Fi stack config t of config t of event data here, SSID and then password, and put it inside parentheses. Copy it and put the password here like this. All right. Now add the break statement as always. If the credentials are correct, we will have to use the case Wi-Fi prov credential success. When the provisioning credentials are successfully received and the ESP32 can connect to the network, we will just print something on the terminal. ESP.tag prov success, and we will stop the provisioning process. And then break. If the credentials are wrong, Wi-Fi prov credentials failed, we'll just print an error on the console. Tag credentials wrong. We will reset the finite state machine, meaning that the provisioning is based on a state machine, which is just a function which takes care of the provisioning states of the initialization and so on. So we'll need to reset it. Wi-Fi prov mgr reset state machine on failure. Like this. We will print the QR code again. The last case is when the provisioning is ended. We will just print something on the terminal again. Prov ended. And we need to deallocate the resources from the provisioning with the function Wi-Fi prov mgr delete. So that's pretty much it. Now we need to initialize the hardware inside the app main. Now we need to initialize the provisioning. And there's some typo here, which is Wi-Fi mode. It should be mode here. And I forgot to add something. I made a mistake. You have to reverse the way of these parameters. So the first one which will come is the proof of possession, and then the SSID. Delete the commas and run the program. Alright, it has printed a QR code. Open the provisioning app, press provision new device, scan the QR code. It will show you here Prov ESP, which is the SSID of the ESP32. Press connect, and it will show you nearby networks. Let's say I'll pick this one, and let's see what happens if I send the wrong password, such as this one. Click provision, and it received the Relia SSID and the password, this one. Wait a little, it says the STA disconnected, STA authentication error. Now, scan the QR code, press connect, and now I'll send the right credentials. Obviously I cannot show you the password on the footage, but you have to trust me. Now it's reset and it's connected. You can see it here, STA IP. The reason why it says here checking Wi-Fi provisioning status is because the app is not working well. If it sees that the ESP32 is reset, it will say that it failed to provisioning device. I can show it that the ESP32 is connected to the network because my computer is connected to it as well. So I say ping 192.168.100.71, and as you can see, it is connected to the network. So having that said, today you have learned how to provision an ESP32. I apologize for recording for too long, but this will serve as a basis for the next videos, because in the next video I will show you how to connect the ESP32 to the Amazon Web Services, and you will be able to send sensor data via MQTT to the MQTT broker from AWS. I'll see you guys later.